For this problem, let's assume that we are being asked to solve a system of equations. So here I have an equation 3x plus 4y equals 4 and another equation of 6x plus 4y equals 16. Notice that conveniently the 4y in the top equation is the same quantity as the 4y in the bottom equation. So an option would be to simply subtract the two equations from each other. And watch what happens when we try to do this. In the x's we have 3x and then we're subtracting by a 6x. 3x minus 6x is negative 3x. So at the end we'll get a negative 3x. In the next part we would have a 4y from the top equation, and that's being subtracted by a 4y in the bottom equation, and those cancel out to become just 0. So I'm not even going to write it over here. And then we also have on the right hand side the number 4 being subtracted by the number 16, and 4 minus 16 is the number negative 12. So we have negative 3x equals negative 12. And this is a much simpler equation to solve because it only has one variable. Divide both sides by negative 3 and you get x equals 4. Now with the system of equations there's actually two solutions, or one solution, but it has two pieces to it, two coordinates. Because the initial equation we had to begin with was 3x plus 4y equals 4, I should come down here and say 3 times x plus 4y equals 4, and simply replace the x value from the original equation with x equals 4. In other words, after simplification, we have 12 plus 4y equals 4. Subtract 12 from both sides of the equation to yield 4y equals negative 8, and then divide by 4 on both sides so that we can say that y equals negative 2. So the final answer is to say that x equals 4 and y equals negative 2.